Hello everyone. At last video we have discussed about the way of describing or writing the concentration of a solution in the various way. Today we are going to discuss about the solubility of gases and solids in liquids. We had already had a discussion that it's not necessary that always that the solution will be a combination of solute particles as solids and the solvent as liquids. We have seen various cases. Gas and gas mixture can be there. It can be solids and liquids also. It can be liquid also. We have seen various examples. So today we are going to observe what will be the tendency of the solubility of gases as well as solids in liquids. Now, before understanding the details about it, let us understand what happens when we take little bit of solute particles, uh, in liquid. See what happens since the concentration increases into the solution, the solute particles dissolves. This process is known as dissolution. So the process of the little bit of solute particles going into the solution is known as dissolution. At the same point of time, what happens in the solution is the solute particles, they actually have the chance of colliding with each other after going into the solution. In that case, some of the solute particles get precipitated out. So this part is known as process of crystallization. So on one side, the dissolution takes place when the solute particles goes into the solution, they get dissolved into the solvent, and at the same point of time, on the other hand, some of the solute particles collide with each other and they get precipitated out. Whenever they were in the solution, they get precipitated out of the solution. In that case, this process is known as the crystallization process. What happens if this process continues? See, if we keep on adding solute particles into a solution, means if the solute particles is added to the solvent continuously, what happens at a certain point of time, the solution reaches to the maximum concentration. So it cannot afford to have more amount of solute particles within it. So this is the maximum concentration that it can have. So beyond that, the solute particles cannot be added, and at this point of time the solution is known as the saturated solution. And if the solution have not reached the maximum concentration yet, in that cases more amount of solute particles still can be added. In that cases, that particular solution is known as the unsaturated solution. So here I need to mention two type of solution. One is the saturated one, where more amount of solute particles cannot be added, where maximum solubility has already been reached at a particular amount of solvent. And on the other hand, when in a particular amount of solvent, when the maximum concentration of the solution is not reached yet, you can add more amount of solute, that is known as the unsaturated solution. So as we were discussing, when the solute is added to the solvent, this forward process is known as the dissolution process, because more amount of solute is mixed with the solvent and the concentration is increased. This forms the solution. On the other hand, what we have said is when the solute particles within a solution collide with each other, so from the solution, the solute and solvent separates out. This process is known as the crystallization process. After understanding the saturated solution, unsaturated solution, dissolution, crystallization, this process, we are going to go into the next topic, which is the solubility of solids in liquids. Now, whenever we mention this term solubility, I need to redefine what it is. Solubility is basically the capability of, in a given amount of solvent, the maximum amount of solute that can be dissolved. So if we take a given amount of solvent, how much solute that can be dissolved, that depends on certain factors. So in this particular case, when we are talking about the solubility of solids in liquids, the factors are basically two factors. One is the nature of solute and solvent, and the second one is temperature. If we see the factors affecting the solubility of solids in liquid, then the mainly two factors which we were discussing is the nature of solute and solvent and the temperature. Now in case of nature of solute and solvent, you see, all the solutes will not be easily dissolvable because of their nature. What kind of nature? Well, it depends on their intermolecular forces, their tendency to react, But there is a way of saying that like dissolves like. What does it mean? Like dissolves like? That means similar compounds, similar solutes, if it is a solid, will be easily dissolved in similar solvent. Now similar means if we take ionic solid, then it is likely that it will be easily dissolved in the polar solvents like water. And if we take, because if we take ionic means that they will be polar in nature. And if we take the covalent solids, or organic solids, then it is likely that they will be soluble in the non-polar solvents like benzene, ether, carbon tetrachloride, etc. See, there are exceptions to this rule, but this is, you can say, in general rule, which is mostly applicable to most of the cases of the solubility of solids in liquids. So what I mean to say is like dissolves like means similar solutes will be dissolved in similar solvents. Ionic dissolves in means polar solutes dissolves in polar solvents, and non-polar solutes dissolves in non-polar solvents. After the first factor, the second factor is the temperature. Now in case of temperature, we must have seen in our daily life, suppose you take a glass of water and you try to dissolve a little bit of sugar. If the water is cold, what do we expect? We expect that the dissolution will be very less. If we increase the temperature, in the same amount of water, the amount of solubility of sugar increases. The reason is the temperature plays a key role in the solubility of solids in liquids. And let us see the reasons. Now here I need to mention that in most of the cases, although by increasing temperature we expect the solubility to increase, but in some of the cases we can see just the opposite way. Now we have to explain the reason why it happens so, and we will see the exceptional cases also why it doesn't happen. Now let us see. Let's see over here. Here we are discussing the effect of temperature. See this graph carefully. We are putting on this axis, you can see 50, 100, 150. We are putting gram of solute per 100 gram of solvent. So solubility is on this axis, and temperature in degrees Celsius is on this axis. So it is 20, 40, 60, and accordingly. You see this different salts: sodium chloride, ammonium chloride, sodium nitrate, potassium iodide. See their curves are not exactly same, and it is in general they are increasing with the increase in temperature. That means we can say that if the temperature increases, the solubility also increases in these cases. So this is the first case where solubility of solutes increases with increase in temperature. Now this is one of the cases. Let me tell you, the reason is like this. I have written this previously just to make the video shorter. See, solute, when it dissolves in solvent, when it is added to solvent, the solution is formed. Now in these cases, for this kind of salts like sodium chloride, ammonium chloride, the process is an endothermic one. The endothermic one means it gives rise to the absorption of heat. So what happens, according to Le Chatelier principle, as we know, even in the process, if the heat is absorbed, now on the left hand side, if the heat is produced, the reaction will go in that direction, going by which it can minimize the effect of change. So if we increase the heat on this side, which is the left hand side, there will be an absorption of heat on the right hand side, which is the endothermic process. So for the endothermic cases, increasing the heat on the left hand side, which results in the increase in temperature as well, actually helps more and more solute to go into the solution. That means the solubility should increase. Again, I would like to say, since it is an endothermic process, since this process gives rise to the absorption of heat on the right hand side, so on the left hand side, if we increase the heat, that means the increase in temperature, more and more solute will go into the solution. That is why for this kind of salts, you can see in the graph, as the temperature increases, the solubility increases. But there is another cases also. In case of lithium sulfate, cerium sulfate, we have seen just the opposite thing happens. The solubility of solids in these cases decreases with the increase in temperature. The reason is, if we explain the reason, it will be like this. See, solute plus solvent, when it goes into the solution, it gives rise to this one. That means it is an exothermic case. If it is an exothermic case, that means on the right hand side the heat will be evolved. So if you increase the heat on the left hand side, it is not going to help to go for the reaction to go into the right hand side. Rather, if you increase the heat on the left hand side, the solution will be separated out. That means the solute and solvent will be separated out. More amount of solute particles will be separated from the solution. So the solubility becomes less. For a repetition, if it is an exothermic process, like for these cases lithium sulfate and cerium sulfate, since the heat is generated on the right hand side, delta H you can see is negative, so it is an exothermic one. So on the right hand side, if the heat is evolved, so if you increase the heat on the left hand side, the reaction is not going to proceed towards the right hand side. That means solute particles will not go into the solution. Rather, what will happen is, from the solution itself, solute and solvent will be separated out, giving rise to the decrease in the solubility. So in this sort of cases, the solubility decreases. Now, the next point is the irregular behavior with increase in temperature. We have already discussed that in case of increasing in temperature, both type of cases can happen. In one case, the more amount of solute can go into the solution, giving rise to the rise in the solubility, and the opposite thing also. But this is a peculiar case. See what happens. See this one carefully. Sodium sulfate, obviously there is 10 molecule of water. With the increase in temperature, initially it rises. Then this temperature, 32.8 degrees Celsius, what happens beyond this temperature, the solubility decreases. Here on this axis, we are putting the solubility, that means the gram of solute by 100 gram of solvent. So beyond 32.8 degrees Celsius, the solubility decreases. So this is a very special case. The reason is this one, already written, that sodium sulfate with 10 molecules of water above 32.8 degrees Celsius, this one actually breaks down. So it becomes anhydrous sodium sulfate. And the behavior of anhydrous sodium sulfate and hydrated one is completely different. So they are in an equilibrium. Above 32.8 degrees Celsius, the water molecule goes away. So it behaves like a different compound altogether. And below 32.8 degrees Celsius, it exists as a hydrated salt. So the behavior of these two components are not same. That is why their solubility is also not the same. So some of the hydrated salts can behave like this way because of their hydrated and anhydrous forms, which remain in equilibrium depending on a temperature. So we have discussed two types of the factors. One is the nature of solutes and solvents, and another is the effect of temperature. The another factor which could be that is the effect of pressure. Now, since on solids and liquids, in both the cases, the effect of pressure is very, very less. They are highly incompressible. So on increasing the pressure, hardly anything changes. So that is why pressure in these cases, that means the solubility of solids in liquids is not that important one. So mainly two factors we need to look up to that we have discussed also. So the next topic will be the solubility of gases and liquids. So there the pressure will be a key factor.